Hi, good morning, everyone. Thanks for coming. My name is Eyal Eizenberg. I'm an engineering team leader at Twix, and also manage the Haifa office, Haifa branch. This is me and part of my team, friend of the Baha'i Gardens in Haifa, just a group of amazing people. We have several locations of engineering across the world, so 3 in Israel, 2 here in Ukraine, 1 here in Kyiv, and 1 in Lithuania, in Vilnius. And in my presentation today, I want to talk about how to build a very complex web page for big scale traffic. We're talking about millions of page views, and we're going to talk a lot about microservices and lazy components and stuff like that. So let's start off by talking about John. So John is a photographer, and he's a Wix user, and he boosts his site with different kind of applications. He has a photo album, and he's writing a blog, he has contacts, e-com, and so on and so forth. And he has many, many back offices. And so he has a back office for sending shout-outs, for contacts, his blog, and so on. And this was actually the case back at Wix a little bit over 2 years ago. And you can imagine this had many issues. And we wanted to make one back office basically to rule them all, to have a concise experience, and that he won't go in. If we look back at the slide here, you see that that's just a sidebar of these back offices. And you can see each one of them looks a little bit similar, but a little bit different. And we wanted to take care of that from a product standpoint and also from an engineering standpoint to see how we can make it better and easier for us. About 2 years ago, like I said, we built this platform, this back office that's called Business Manager. This is an amazing platform which is built by colleagues of mine at Wix. And basically, this is the back office which renders all the back offices across Wix. So photo albums, the booking services, and so on. All these things together live in this one giant back office. And you can see there's only one sidebar now, and it serves all these stuff that we said before, the photos, the bookings, whatever. And like I said, about 2 years ago, when we started working on this, we got this feeling that we need a dashboard. We need something to help show information to the users from different verticals and horizontals. So if we're talking about what are these things, basically it's either something which is unique just for this kind of type of user. So if we said he's a photo albums user, he's an e-com user, and so on. So these things which are unique to him, and he needs to see information about these things right when he goes into this back office of his. For example, if he's an e-commerce user and he has a new order, this is something he needs to see immediately when he goes into this dashboard. And there's also things which are kind of like horizontal, what we say, which are across all the different applications which you have installed on your app. For example, how to manage your site, how to edit it, rename it, add contributors, and so on. Here you can see, for example, common actions, which are across all the different applications that you have on your site. Getting domains, sending emails, and so on. And here you have something which is specific just for one vertical. In this case, it's the blog. You can see tips on how to create your blog, and so on, and get more information on it. So when we started building this, we built it with using React, Redux, and TypeScript. And what would happen was that it was one big client-side repository, one static bundle, and it would render these different kind of widgets with direct NPM dependency on them, and you would get this dashboard. When you went into the back office, you would see something similar to this. The sidebar would load, and you have this spinner going around until everything was ready. And the first thing we did was we added a skeleton in order to improve perceived performance. Who here knows what perceived performance is? Okay, so only 3 people. All right, so let's talk about it. perceived performance, I think it's one of the most important things when it comes to web design. Perceived performance is not how fast your website loads, it's how fast it feels to the users. So all of you, for sure, have seen something similar to this. When you go on Facebook or LinkedIn or Twitter or something, you're seeing this skeleton, basically, of how the page is going to look when it's ready. So compare this to this, what we saw a second ago. You're looking at this thing is going around and around in circles, and especially if you're on a bad connection, it feels like it loads forever. But if it started out like this, and then 1 second later, it changes to this, you're already kind of getting a feeling of how the page is going to look, and it feels like it's going faster than it might actually does. So for example, it would take the same amount of time, but this feels like it's going much, much faster because things are changing. And you can already look at this, and you can imagine that over here there's going to be some sort of thumbnail of the site with some information on it, and some other widget here, and you get the point. So perceived performance is very important, and if you're not paying attention to it right now, talk to me after this presentation, and let's see how you can get going with that. So we built this dashboard, but it had several issues that we noticed quite quickly that we wanted to address. So first of all, let's talk about the performance. So it was one repository, indeed only client side. There was no server side at all for this. Everything was static. And it had all these widgets built into it by direct NPM dependencies. So for example, just the site detail, that thing which is going to appear over here, that was 115 kilobytes. And you're probably saying to yourself, 115 kilobytes is nothing. I take a picture with my phone and it's 4 megabytes. But you have to consider that as your app grows and your business grows, you're going to have to cater to many people with different kinds of connections. And a lot of them are not going to have a great connection, whether it's while they're on the mobile device and they're going throughout the city or in the country or something, or if we're talking about new and emerging countries that are just joining the internet, like places in Africa or in Asia, and I'm not talking about like Taiwan or something, right? And for these countries, or with people with lower speed connection, 115 kilobytes is a lot. And we're monitoring all this with graphs and everything, and we can see how fast it takes to load something that size on connection here in Israel or in Ukraine or in the US, and how fast it takes in, I don't know, somewhere in Africa. You'll see the difference is huge. So slicing down the size of your bundles is important, and we're going to talk a lot about it in this presentation. So in addition to the performance, we had also an issue with perceived performance. So indeed, this was much better than that spinner that we had before. But the problem was that we had this skeleton, and it was loaded up pretty quickly. But in the background, these widgets were getting ready to display themselves. They were fetching information from servers, rendering React DOM, and so on. And each one of them would be ready on a different time in the timeline. But the problem was that the slowest one of them would set the tone. The slowest one of them, when each one of these widgets would say, I'm ready, I'm ready, I'm ready. The last one that said, I'm ready, then the skeleton would disappear and you would see the page ready. So that was a problem. It was an improvement over a spinner, but still it's not as good as it could be, and it still felt slow, especially as we got more widgets, and especially if you went to slower connections, like I said before. In addition, we had product issues that we noticed and we wanted to take care of. For example, we have this setup widget, what we call, and this widget, basically, it helps the user get going with his business. So if he's an e-commerce user, then it would instruct him to first add a product to his store, add a payment method collection, like PayPal or something, or Visa, I don't know, publish his site, and so on. And once he finished these steps, this widget would disappear. And each one of these verticals, which was integrating into our dashboard, could add setup widgets like that, each one with like 3, 4, 5 items, and it began to look clunky. Imagine if you have the example from before, so you have e-com steps and event steps and main funnel, which is basically the steps that every site has and gets it and is supposed to do in order to succeed, like connect domain and publish your site and so on. So this became clunky, and it took a lot of real estate, and you can imagine that this was expensive. Complexity. I mentioned Redux earlier, and it's just by chance I added this on the flight over here. Dan Abramov, I'm assuming everybody here knows him? Yeah. So Dan Abramov is the guy who wrote Redux, and he came up with this 3 days ago, and he basically denounced Redux, and he said that it's terrible and it's incredibly frustrating. I'm not sure I agree with him because I was a pretty big fan of Redux, but I can definitely say that it's very hard for new developers to join your code base with Redux. It's, just for fetching data from the server, like he said, you need a container and a component and action and a reducer and selector and join reducers and mass reducers and all that stuff. It gets pretty complex, and if any of you are old like me, you remember the days of just $Ajax and you're done. So this was, I can definitely relate to that. And especially if we're talking about junior developers who don't even know Redux, it's completely crazy for them, and it's very hard for them to get into it. All right, we're okay. So from all of these reasons, we decided that it's time to fix this dashboard and see how we can make it better. So this was dashboard 2.0. It has some of the components that we had in the previous dashboard, but we organized them better. So for example, here, this is the main setup widget. It holds all the other widgets together, and this is customizable by the other teams. They have an API that they can hook into it and display the information which is important for this kind of site. The site details as before with the actions you can do, help, and so on. And this is some of the stuff that we noticed about it. So first of all, performance-wise, we did separate widgets. All the widgets were now extracted from the main repository. And now the main repository, the dashboard repository, was very, very small. And all it did was bring the other widgets using lazy components. Who here uses... Cool. Who here uses lazy components in production? Okay, so only a handful. I think I saw less than 10 hands. Who here knows what lazy components are? Okay, so most of you do know, but a lot of you don't, and most of you are not using it. So let's talk a little bit about lazy components and why they are important. So a lazy component, basically the parent, in this case, the dashboard, it loads up, and it's very, very small, so it loads up quickly, and we're showing these skeletons, like I said before. And underneath these widgets, nothing is being rendered, because there are a lazy component, which is a very small piece of code. It basically instructs the parent where to fetch the bundle for the child, for the widget in this case. And while it's fetching, so the data is being fetched, the bundle is being fetched in the background, and the skeleton is showed. And when the bundle arrives back to this to the widget is ready, and in its component did mount in React, it tells the parent, "I'm here, the bundle is ready, show me." And then basically the skeleton disappears, and you can see the widgets, and everything seems faster. This was one of the most crucial things that we started off by doing. I did not mention this, but can anybody guess the traffic for this dashboard? How many unique users per day? Raise your hand if you think it's 100K per day. 200K, 300, 400, 500. All right, so it's on average between 4 and 500K unique users per day. That's not even views, so views is a lot more, but unique users per day, it's about 4 to 500,000, even sometimes more. So it's a lot of traffic, and in order to fix this, we had to really slim down the bundles and exactly slice them the way that we needed to. So that's why we chose lazy components. It really helped us. Let's talk about the benefits of lazy components. So first of all, it's many small bundles instead of one big one. Let's, for example, say that the dashboard itself weighs 50 kilobytes. And each one of these widgets is 100 kilobytes. I showed you earlier that that site details bundle was 115. So let's say 100. So we have the dashboard, which is 50, and 6 widgets, which is 100 widgets, 100 kilobytes each one, so 650 kilobytes. So just imagine that 500,000 people who go into this page will need to download 650 kilobytes. You're saying, okay, it's not that bad, 650 kilobytes, not that bad. Let's for a sec forget about the slow connections. The problem is, first of all, that the performance can suffer greatly when you do a change. And that's what I said here when I said incremental performance. Because imagine that just at that top where it said dashboard, I wanted to change it to my dashboard, okay? I would make that change, and basically the entire dashboard package would have to be compiled all together. So that 650 kilobytes all over again. And it meant that the same users who just saw this dashboard 10 seconds ago and are now reloading the page would have to re-download that 650 kilobytes just because the browser tells them the bundle has changed, you need to re-download it. So imagine that again, all these people have to re-download the entire bundle again. If you have different lazy components, these microservices, as very commonly known, it would mean that if you made a change only in one widget, only that bundle needs to be rebuilt, and only that bundle needs to be re-downloaded. So when you go into the dashboard and you reload, the browser will tell you for all these separate bundles, it will give you 304 status, meaning unmodified. And only for that one widget you would have to download. So only 100K. So that's important. And again, consider slower connections all the time. In addition, having small micro front ends like this, it gives you a lot of confidence in deploying them. If you change something small, but you have to rebuild the entire bundle all over again, you have to consider that maybe you did something here, but you broke it over here by accident, because all the code lives together. So you probably have to check everything all over again. So whether it's automated tests, unit tests, or even manual tests, you would have to check everything. But if you have a micro front end over there just for this widget over here, if you change it, you know that you only need to check it. There is no way that you affected the rest of the things, especially since each widget is it's covered with try-catch on it. So if it fails, it will just disappear and will not break everything. Error boundary in React, for those of you who are using it. So it gave us a lot of confidence that we can deploy just parts of the application without having to check everything. Also, in my opinion, it's much easier to test. It's easier to test a small piece of code. Also from the logic, from understanding it, you don't have to mock a lot of things. You just have to check something very simple. Think of it if you want to check just one function, it's so easy. But if you want to check an entire application, it's a lot of things. You have to mock a lot of things, make a lot of things. Also for unit tests and also for integration tests, so it's much easier. And one important aspect here is that we had a much needed improvement in perceived performance, because now you would get something like this. All these skeletons would appear, and as each widget is ready, it would change, and you would already see the widget itself. And in this case, this widget is not ready yet, so you're still seeing the skeleton, and once it's ready, it changes. And this is very common practice. I didn't invent this or anything. It's very common practice in many applications, and if you go right now into your phone and go to Facebook or something, you're going to see like a circle of your avatar, and it's going to change, and then the feed will appear. This really improves perceived performance, and there's also a key metric called time to interactive, or TTI. At this point in time right here, I can already start interacting with my site. I can search for help. I can do some actions already. I don't have to wait for everything. So this is an important thing to take into consideration with using lazy components. From a product standpoint, I know all of us, or most of us here, are developers, but the product was also a great improvement for us, and we improved conversion and completion steps and other KPIs. So it was really something that affected us positively. Something I want to talk to you about again, or now actually, is the dev velocity. Before, we had all these developers working on one repository, and since most of you are not using lazy components and microservices, I think you're probably going to relate that if you have many developers working on the same code base, you're going to step over each other's toes. You're going to have merge conflicts on the best case scenario, but on the worst case scenario, you're going to change something here, and another dev is going to change something here, and you're going to get business logic conflicts, and then you have to solve them, and if that developer is away, it's even more complicated. So now we had all these devs spread across these many, many micro projects, and it's very easy to maintain them. It was easy for them not to collide in their work. In addition, because these projects are small, it's very easy to bring new developers on board, whether it's juniors or not, even senior ones. If you have a small project, you know exactly how it should look like. The code base is small, the test suites are small. It's easier to get into it, and I'm sure everybody can relate to that. You get a huge project, it's super complicated, you don't know where it starts, where it ends, and like I said before, with Redux, it gets even more complicated. Even though I love Redux, I can really understand the headache when going to a new project there. Something also cool we did on the way was we switched to internal serverless solution. It's obviously just internal, but I really recommend something like that to all of you here. How many of you here are using some sort of serverless solution? Okay, so very few. If you're not using serverless, and I know it's like a big buzzword, and I've heard it many times in the last 2 years, but I only got around to really trying it in the last half year. This really helps developers, especially front-end developers, which are not accustomed to using server-side code. We have a team of 4 feds right now, and once we got into using the serverless, which is as easy as writing any JavaScript function, all the team was switched from just front-end developers to full-stack developers. And it's the same. All these platforms are the same, whether it's Amazon or IBM or SiteNow. All of them are the same. You just write a function in JavaScript, and it runs on a server, and you don't have to take care of nothing pretty much. So I really recommend it, and it really helps the velocity because you don't have to look for a server developer or, oh my God, I need to get a server up and running, and how do I do this, how do I do that? It's really easy, and I really recommend that you integrate serverless into your applications. Now I would like to discuss some common issues and optimizations that we had in this refactor or redesign of this dashboard. So obviously, not everything went so great and so well, and we had issues, and I'm sure most of you or any of you who have used microservices in production will relate to these problems, and hopefully you like the solutions that we suggested here. So the first major problem that we had was with the lazy components. We talked about them before, how we said it was great that the bundle would be fetched in the background, and then once it's ready, it will switch over from the skeleton to the widget. However, you need to take into consideration that 99% of the time, when you're rendering some sort of React component, you're probably going to also fetch some information from a server, unless it's static content, right? But most of the times, you need something from the server. So if we're looking here at this timeline, you can see that the parent loads the lazy component, it fetches the bundle in the background, and only once the bundle arrived, the data begins to fetch, and once the data arrived, only then the component can render the content and tell the parent that, hey, I'm ready, switch over. And you can see the problem here that it's serial. Okay, only once the bundle arrives, then the data begins to be fetched. And this was really hurting the performance because why wait for the bundle to arrive to start fetching the information? So what we did was the solution was simultaneously fetching both the bundle and the data at the same time. We changed our lazy components not only to instruct the parent where to get the bundle from, but also we gave them a function, like we called it data resolver, that this function which is a promise, once it's resolved and the bundle is resolved, basically the resolvement of this data resolver would go on to the lazy component as props. So if, for example, you're fetching something called users, then the entry-level component in your bundle would get a prop called users with this information. And they're fetched at the same time, and once they both arrive, basically your component is ready. So think of it, for example, instead of 2 seconds to fetch the bundle and then 2 seconds to fetch the data, so you have to wait at least 4 seconds. Now you only have to wait 2 seconds because they're fetched at the same time. Another issue that we had, and this is very common, is increased bundle size due to duplicate dependencies. Because now all these micro frontends need to take care of themselves and do certain things, for example, fetching information from the server, logging some BI, logging sentry errors, and so on. They all have to bundle in them these dependencies and these tools that they're using all the time. And we easily noticed that all these widgets have a lot of common dependencies together. So what we did was basically we extracted the common dependencies from these widgets to the top level, to the dashboard. We actually split that dashboard project into 2 projects, the dashboard and the dashboard API. And the dashboard API was kind of like a hub of like a toolkit for all these widgets that they can use to get like information that they needed. So for example, we extracted the Axios, which is a common XHR package. We extracted it to the dashboard. And this widget, for example, instead of calling import Axios from Axios, it would import the dashboard API, which was a dependency of it. And then it would say dashboard API dot get Axios instance. So in this case, all these packages were just bundled into the top layer. So indeed, the dashboard itself loaded a bit slower, but take into consideration that the dashboard, this platform for all these widgets, didn't change much. So even if we did add these 5-10 kilobytes of packages each time to this dashboard, it didn't change much. So all these users, when they came back, they would get a 304 code, and it didn't have to re-download the package. So the widgets are the things that change a lot, but the platform did not. So that's why it was easy and was a good decision to extract these things out. This goes also for common code. I'm sure you have many pieces of code across your production environment that you're almost copy-pasting because you're saying, I'm not going to put this in an NPM package, I'm just going to copy it, it's too much work, blah, blah, blah. So not only is this wrong because you're repeating yourself all the time, but it also bloats your bundles because you have to write this code in each bundle. So again, common things we extracted out. For example, we have a BI logger that we're using, and we wanted to extract the code how to initialize it because we saw that it keeps writing itself all the time. And when you start a new widget, First thing you do is you go to another widget and you copy that initialization into your project, which seemed ridiculous. A common problem that we had was with translations. Who here knows this diagram? All right, so less than half of you don't know what this is. This is the Webpack analyzer. I use this tool, seriously, every day. And I love it. I think this is one of the most important things a web developer needs to do on a daily basis. The Webpack analyzer, basically, it's something that comes built into Webpack. You just pass -- analyze to it, and it makes this JSON file in the background, and you get this diagram automatically in your browser. Basically, it shows you, for your bundle, in this case, this one, this is what it's comprised of. So you can see, in this case, that it's made of a lot of node modules, and this is usually the case. Because usually, when we want to do something, the first thing we do is we check if somebody else already did it. Because they will say, yeah, it's more maintainable, and they did it, and it's tested, and blah, blah, blah. But usually, this brings a lot of code in and a lot of unneeded kilobytes. And we'll go into that in a sec. But let's first talk about this one. So Wix is an international company, and we translate the code to many, many languages. I think there are like 30 languages just in this diagram. And you can see that it weighs a lot. I don't know if you can see it from the back, but this is 126 gzipped kilobytes. This is a lot. And think about it. You're going into your dashboard. I'm using English, right? Why do I care about fetching translations in Italian or Thai or Hebrew or whatever? I don't. I clearly don't. So what we did here, basically, we changed the way that we use these JSON files. Instead of bundling them all together in the application, which is a very common practice, basically we decided, let's just fetch the JSON that we need. Each one of these JSON files is not that big, but once you have 30 of them, obviously it's huge. And you can see here, this is a screenshot I took a while ago of the same component before I extracted the translations and after. And this was the first step I did, and you can see the results here from almost 300 kilobytes to 169 kilobytes just by extracting these translations. And if you're using, for example, I'm sure it's with many translation packages, but we're using I18 Next. I18 Next comes built in with this. You just pass to it .xhr, and it tells it, instead of looking for the JSON file here, fetch it from there. And that's it. That's all you need to do. A bonus thing, which I also suggest to do if you have a relatively big company, you're missing, I can't see the number. Thanks. If you have a relatively big company, we have a lot of translators for many, many languages. What would happen is that they would change the translation, and then they would tell us, hey, can you please GA this project because we changed the values of some translations. And obviously, this would get annoying in addition to being kind of dangerous. What if I don't want to GA right now? I have some risky code that I need to QA first. I can't GA this right now. Or maybe I'm blocked by something. So what we did was we made the translations project completely deployable. The entire project is just JSON files. And that means that the translators could change the values, and they could GA the project. And on the next reload, you would get the new translated values without even having to talk to us. And developers don't like talking, right? OK, browser throttling. Before I show this part, who here uses HTTP 1 and who uses HTTP 2? So HTTP 1, HTTP 2, who has no idea what I'm talking about? All right, awesome. So many microservices means many network calls, right? If we have old school project, right, where we're fetching everything from the data at once, from the server at once, or we're even preloading it into the HTML. But in many microservices, front-end microservices means that we're doing a lot of calls, network calls. So if we have 10 widgets, it means at least 10 of these calls happen at the same time. And HTTP1 is an older protocol, which is in all the browsers. And it has this limit that many people don't know about. I didn't know about it either, to be honest. It limits the browser to 6 concurrent requests to the same host. And that means that if I have 10 widgets and they are making requests to www.wix.com/API, whatever, it means that the 7th call is waiting until the first call finishes. And only when that call will finish, the next one will start. And basically, all the requests are queued. They're waiting. They're stalled. And you can see here in this image, this is a real image I took of one of these widgets when I'm fetching the data for it. And you can see that it's stalling for half a second. And I'm going to show you 2 more slides of this same thing in different network connections. I used the network simulator for Chrome for the Chrome developer tools. Here I'm online, meaning there's no throttling. And you can see that it's stalling. It's just waiting, not even starting the call for half a second. But the call itself, it takes less time than the time it's waiting. So the duration was like 300 milliseconds. The wait was half a second. The total is 813 milliseconds, which is ridiculous. Let's look at fast 3G. Okay, fast 3G stalling for 1 second and a third, but the fetch time is half, only 600 milliseconds. And if we go to slow 3G, again, developing countries, mobile devices, stalling for 5 seconds. 5 seconds. Think how long that is. And the actual fetching was just 2 seconds. It's ridiculous. It take more than double, and we're talking about seconds, not milliseconds anymore. So the solution here is to switch to HTTP2. Take into consideration that if you're using Express and Node, by default, it's not available yet. It's only going to be available from the next version. But if you're using things like Nginx or some other network load balancer, they do support it. So you can do from the client to the Nginx HTTP2, and then it does HTTP1, because from server to server, there's no limit. It's only from the browsers. And basically, that means there is no limit on concurrent requests. You can have as many requests as you need, as long as your connection can handle it, basically. And another thing we did was we said, OK, we have this problem with too many requests. We analyzed and we looked for similar requests, which are the same, and we bulked them together. We said, for example, we had different widgets that ask, is this user an active user? And by active user, I'm saying, did he publish his site? Did he upload a product to his store? And so on. And we had 3 widgets asking the same question. And by asking, I'm saying making a network request. So what we did was we cached the requests together in a promise. And once the promise was resolved, all the widgets knew the answer, the response was shared, and we changed 3 requests into 1. So combining that with HTTP2, let's look exactly again at the same data fetching on different network requests. So this time, again, no throttling, stalling for 3 milliseconds. But the network time is obviously the same. I can't make your network faster. But now the whole response, the whole cycle was just 340 milliseconds. On fast 3G, again, almost no stalling and same network time. And let's look at the slow 3G. Remember how long it was? 5 seconds before? 2 milliseconds, same network time. So instead of 7 seconds total, just 2. So this was a dramatic change, and it's something very important that you need to be aware of. Bundle size due to unique code. Different widgets have different unique codes and different NPM dependencies. Remember we talked about big NPM dependencies before? So I noticed that I have this widget. It's called Omni Setup Sidebar. This is actually a widget that lives in this sidebar at the top, small part. it shows you how you progress along with your initial setup of your site. So the different things that you need to do, like 7 steps or something. And once you complete these steps, basically you get this little tooltip that opens with a nice animation that shows you a happy moment, and it says, congratulations, you're finished, you rock. And I noticed that the bundle size was very big for this thing. And I ran the NPM, the Webpack analyzer, and I noticed that there are 2 very big squares here. Loti and the tooltip happy moment JSON. Loti is a very cool package which basically lets you get animations from your UX designers, from your animators. They export it from After Effects or something like that, one of these designer tools, to a JSON, this tooltip happy moment JSON. And you take this JSON and you pass it into Loti, and it makes this animation ready for you. So just think of it of like SVG on steroids, and it changes completely in different sizes. You can scale it up, scale it down. You don't lose resolution because it's just like SVG, but animated. If you're using GIFs, you know the problem that they look terrible. In order to make them look good, you have to make them very high res, and then they load a lot of time. So this is the solution, and it's pretty great. But like I said, it weighed a lot. So you can see here, Loti weighs 62 kilobytes, and this JSON was even more. So it was like 120 kilobytes just for this animation and the happy moment. To get all together, the component, the entire bundle was 189 kilobytes, almost 190 kilobytes. And this is the happy moment. It's not animated here because it's a screenshot, but basically just for this thing. This thing here was like 120 kilobytes. So the solution here, it's before we were talking about an engineering solution, there is a product solution here. You need to understand the product very well and work with your product managers to see when you need to do something. So you can see here it's 7 steps completed, right? So while this user is in this dashboard and there are 6 steps being completed, even the 7th one, this animation is not being shown at all. We only need to show it once you complete that 7th step. And you don't even complete it from this progress bar. You just complete it by doing some actions. For example, publish your site, if that's the last step you need to do. Once you publish the site, the servers in the background tell each other that, okay, he completed this step, and it tells the client using WebSocket that, okay, pop this thing up. So only at this moment, we need to show this. And the user won't care if this tooltip appears immediately or half a second later. He won't even notice it. He won't care at all. This is a crucial thing to understand, that if you're looking at the product, you can improve the engineering side of it. So what we did here, we used Webpack and React code splitting. Do everybody know what it is, or not so much? All right, so code splitting is pretty much what it sounds like. There's a feature baked into Webpack, and it's also baked into React by default. It's called React Lazy or Suspense, and you can use directly the lazy loading of Webpack. And it means basically that you're taking your bundle and you're splitting it to chunks. So you can see here, it's the same bundle, Omni Setup Sidebar, but now it has 2 more chunks, 1 chunk here, and the number is just randomly generated by Webpack. And basically, all this chunk has is that JSON file and Loti. And this chunk over here is about the entire tooltip, because this progress bar only appeared on certain conditions. So there was no point in fetching all the bundle together, because maybe the tooltip won't be shown at all. And if you can see, I don't know if you can see it in the back, but the bundle size decreased to 38 kilobytes. Remember how much we started with? 190 kilobytes. So this is very important. Talk to your product managers, understand the product, don't just code, don't just far away. Think how you can improve ahead of time. The last thing I want to talk about is some issues that we're facing moving forward. This is stuff that we're actually facing right now and we are working on. in order to fix. One of the issues that we have is what we call disappearing skeletons. So when we started, you saw there were only like 5 skeletons, and these widgets would appear 100% of the time. But now many other groups at Wix, they integrated into our dashboard, and now we have many, many widgets, all these potential widgets. And what would happen is that these potential widgets, they would fetch information in the background, and they would decide, do I need to show myself, or do I need to tell the dashboard to hide me completely? Because, for example, you're not an active site, or you're not a Wix code user, or some other thing. So many of these widgets would disappear. So for example, here you saw we have many, many skeletons, but less widgets. So this is a product problem here that we wanted to take care of. But in addition, this problem, and this is a problem that you need to take into consideration when you're using lazy components. So we have the dashboard, and it's using these lazy components. But the way the dashboard knows how to fetch these lazy components, it's basically that there is a small dependency, a very small one, but it's still there in order for the dashboard to just activate the code that says, fetch what I need, the bundle and the data. You don't want to write this code into the dashboard. You should have an abstraction layer, like encapsulation, that you don't know how to fetch and in which way. So there is a small piece of it which is run by direct dependency. And the problem is that if, for example, widget A here breaks because of lint or TypeScript or even a real test which breaks because of whatever reason, it means that this dashboard build is now broken. And we can't make new versions of it. We can't deploy a new version because our build won't even start because there is dependency there. So the solution that we are working on right now is basically to calculate the layout in a server. And like I said, because we're now using the serverless and we're very happy and confident about it, we are not afraid of doing it as we did before with just client side. You know, we wanted to do everything in the client side. Now we're reaching a point where we need to do complex calculations on how to render it, and we want to do it in the server quickly because there are a lot of benefits for it. So first of all, the widgets will register to this layouts service instead of us basically writing them, adding them to us via direct dependencies. The calculations will be done in the server, so you won't get the disappearing widgets, the disappearing skeletons anymore, because once the skeletons will appear, 100% of the time, these skeletons will transform into widgets. We're going to remove completely the build dependencies because now the server will just make the calls according to whoever registered. He won't even know who is registered to it, potentially. Like I said, the skeletons will only appear for relevant ones. And the data will also be fetched on the server. This is important because when you're making a network request from a client to a server, the thing that you usually, unless you're doing like really complex calculation in the server, usually the thing that takes the most time is the hop from the client to the server. The server responses are usually in the 30 milliseconds time frame, something like that, depends what you're doing. But the client hop can take a lot more. And when we're doing server-to-server calls, they're very, very fast. We're using gRPC to make these calls, and it's very, very fast. It takes a few milliseconds just to make these calls. So if you have 10 services that you need to call, it's very, very fast. And you can imagine, depending on how many widgets you have, how much time you're wasting in the network. And also, again, think of your slow connections. This is something important that I said a lot of times throughout the presentation, but I really think about it because all these hops, all the network time, this way we're passing the responsibility to us, to the developers, to the server, and away from the client. We don't have to worry that they might have slow connection and it might be hard for them. And these servers will also return the lazy components, so it will be fetched, the bundle will be fetched in the client as before in order to make the client load really quickly. So to summarize, this was the case study that we had about this thing. It was a long process. I mean, we did it in 50 minutes here, But generally speaking, this was a process for like 2 years, and I think we learned a lot from it, and hopefully you did as well. It's important to consider what you want to share between your services, what's important to share, what's important to break apart, what can you reuse, and use the Webpack analyzer. There are more tools like it that will help you explore and investigate even further. And in addition, always think of the slow connections. Use that throttle in in the Chrome developer tools, and see what happens when you change your application from online, meaning no throttling, to slow 3G, and see just for yourself, do you think this is a good experience? Is it tolerable? Or is it something horrible that you just want to kill yourself? So this is important. If you're in a tolerable or kill myself situation, probably something is wrong, and you can improve this much, much more. Thank you very much.
So, okay, we have some time for questions. Does anybody want to ask? It seems that no. So, okay, let's answer. Oh, sorry. Yeah.
So, first of all, thank for your talks. I want to ask you one question. What tools exactly do you use to check performance of your dashboard?
We're using, so first of all, there's you mean like monitoring it?
Yeah, monitoring and check performance. You already mentioned Webpack analyzer and Google developer tools. What else do you use?
So if it's server performance, we usually use a New Relic for analyzing the performance, how long it took. It's a very great tool. It's a little complex, but once you get used to it and you understand it, I think it's great. For the client side, we use Grafana, which is basically a tool that helps visualize raw data to it. What we do is that we send small events, small AJAX calls, like really tiny, less than a kilobyte, when an event happens, and then we can know the difference between it. So for example, when the dashboard begins to load, we send an event called dashboard began loading. When that spinner shows, another event. When a widget, and this is important, this is on a big screen TV in my office, when a widget starts to load, we send an event, and we send another event when it's loaded. And then basically this tool, it shows you the success rate, because if you sent this a widget loaded, began loading 100 times, but you're only sending the finished loading 90 times, it means that you have 90% success rate, and the other time you're not. In addition, you also know the load time, because it calculates the delta between it. So we use that a lot for success rate and for load time. And obviously, we have many, many of these events, so we can see, and over time, how are we improving or not.
Okay, thanks.
Okay, let's thanks again to our speaker for this interesting topic.
Thank you.